Thanks, Joel. Thanks for everyone for coming. This is actually my first in-person talk since 20, whatever year it was that I last gave in-person talks. So if I stare weirdly, it's probably just because I'm not used to this anymore. So actually the previous bit with Ben is a good sort of foray into what I want to talk about, which is really this tension that we've had. Okay, how do I get the slide to go? There we go. This tension that we've had around full automation via AI techniques and giving users control, for instance, through interfaces. So this is a quote I pulled out from Marty Hurst that she wrote in IEEE-IS. And this is certainly a bunch of debates that have been, sort of very prominent over the past few years. Ben's book talks a lot about these things. It turns out Marty actually wrote this back in 1999. These tensions are nothing new. And yet, one of the things that we see is that, I come from sort of the AI community, and our collective view of the world is automate everything, right? Like everyone talks about like AGI these days. And I think there's a shift in parts of the community away from automation and toward developing the sort of technology that gives people control, but it's certainly not ubiquitous across the whole field. So what I want to talk about is some work that we've done in this space, and I'm going to motivate this through a project that I've been working on with Trista Tsao, lovely Francis Domingo, Sarah Gilbert, Katie Shilton, and Michelle Mazurek, and I'm not sure why the names don't match the photos at the end, sorry about that. And so the setting that we've been looking at is one of automated content moderation, in particular on Reddit. So Reddit is moderated by a bunch of volunteer content moderators who have a relatively small but very useful amount of technology that helps them do their job of content moderation. And the question that we're essentially asking is, how can we give them more support in the job that they're trying to do? So to give a sense of what they actually do, what their sort of workflow looks like. So someone will post something on a subreddit that they're moderating for. And then this is an example from Ask Historian. So every subreddit has its own policies about what sort of content is appropriate or inappropriate in that space. These are 17 things that can get your post removed from Ask Historian. So things like plagiarism, speculation, moralizing, digression, etc. And so the person's job is to identify if this post violates any of these regulations. And some of these are very subtle and require fairly in-depth reading of what's said. So this is quite a difficult job. And what we're trying to do is we're trying to say, well, okay, people are really good at a lot of things. So they're really good at reading things closely. They're very good at understanding nuance, intent, meaning, things like that. But any subreddit is moderated by a large number of content moderators who won't have seen everything that comes through. And so one place where tools might be more useful is coming from the fact that they can synthesize information across a huge body of text that any individual moderator won't have seen themselves. So the way that we're sort of thinking about this is some sort of interaction, which I'm going to depict as a dialogue, although dialogue is probably not the right metaphor here, despite everyone in my side of the world being so excited about chatbots. I think chatbot for content moderation is probably not the right approach. But you could imagine something where there's an interface that reveals the fact that the underlying tool believes something about the rules that this post might have violated. The person may be interacting by giving some feedback on this or asking questions about why it violates, say, plagiarism. The machine, which is particularly good at identifying things like plagiarism, might be able to give a bit more information. And this can go on until the person is comfortable making the decision that they want. And our hope is that this sort of approach would increase both consistency, but also things like accountability and transparency in the decisions that are made. So the sort of premise that I'm going to use for the work that I'm going to talk about is this notion that communication between the person and the tool is a way of enabling user control because it gives them more information with which to make their own decision. And this communication can take multiple forms, but in general, it'll be bidirectional. And probably the person is going to be learning, the machine is going to be learning. And so all of these things have to happen within the space of co-adaptation between the sort of two players here. Okay, so to start with, I want to give an example of a particular type of communication, which has largely been called explanations or interpretability in machine learning or artificial intelligence. So the idea here, this is a pretty well-studied field at this point, is that a machine can make a prediction about the outcome, say that this violates anecdotes, but it can also try to provide some sort of justification for that decision to help the person contextualize it and decide whether they want to agree with the sort of suggestion made by the system or overrule it. So it turns out that despite there being a fairly large literature by now on interpretability in machine learning systems, sorry, I just have to rearrange things a little bit. So although the goal for these sorts of systems is to explain system behavior to people, for the vast majority of studies, people arrive in the study as an afterthought. And that seems a little bit strange. And so in work with David Alvarez-Melis, Harman Kaur, Jen Wortman-Vaughan, and Hannah Wallach, we aim to put human needs at the center of both the design and the sort of final evaluation of interpretability tools. So not surprisingly, it turns out that how people explain things to other people has been long studied in humanities, law, social sciences, philosophy, and so on. And if you do a read through a large quantity of this literature, you find a handful of recurring themes that human explanations adhere to. So for instance, human explanations tend to be contrastive. They tend to be counterfactual. So I explain not just why something, but why not something else. And they tend to be sequential. So I don't explain, my entire reason for coming to University of Maryland in like one giant document. I say like, hey, I wanted to live in a city and there are really great students here, right? And then like, if you're interested in more, you can ask me for more and we can have this, this sort of like drill down effect. Machine explanations basically don't do any of these things, except perhaps a little bit on counterfactuals these days. But generally they tend to be absolute, non-contrastive, and very one-shot. And so we set about first designing a set of principles that a explanation system should adhere to if it wants to support the needs of people, and then designing a system that, that we hope at least partially supports these. So the first is we want to be able to explain, why is this plagiarism versus something else? So this is contrastive. We want to be able to decompose explanations into atoms of different granularity, right? So I came to Maryland because there are great students, right? Well, there's a lot that's packed into that. And at some levels of granularity, you might want to break it down anymore. We want things that are parsimonious, so I don't want to be explaining based on things that don't actually matter. Things need to be intelligible. I mean, this is maybe kind of obvious, but if these things are going to be mathematicalified, whatever that word is, we need the quantities to be understandable by humans. And so this includes simple things like humans can do addition in their head. Humans can't really do multiplication in their head. So if we want things where we want people to be able to reason over numbers, we need to do it in a way that they actually can handle it. And then we need to exhaustively explain everything else away, right? So like, why did I come to Maryland versus sort of anywhere else in the world? Okay, so we have a proposed solution for this. I'm not going to go into like too much of the underlying details. You can certainly read the paper for that. But it's based on this principle of weight of evidence, which came up in the late 1800s, but was really popularized in the 1950s and 60s. And the idea of weight of evidence is it's a statistical measure that says, given some hypothesis, such as, does this post violate plagiarism? how much does some evidence speak in favor of that, right? So if it has 5 words copied from somewhere else, how much evidence does that provide, or what's the strength of that evidence in favor or against plagiarism? So to give an example of how this looks in practice, so this is a really simple example for trying to predict whether a patient has a flu. So a patient comes in presenting some symptoms. In this case, they have a cough and chills. Based on the underlying machine learning model, which has been trained to predict flu given a bunch of systems, we can compute these weight of evidence scores for each of these features. So it turns out that cough and the presence of cough and the lack of dyspnea speak in favor of flu, whereas the presence of chills and the absence of fever speak against it. And so it turns out that these quantities are nicely additive, and so you can achieve some sort of total evidence in favor or against flu by essentially stacking these bars. Okay, so that's sort of the crux of how this is working under the hood. We built a tool around this in a Jupyter notebook so that we can conduct an artifact-based interview study with a collection of data scientists. So in this study, we first provided the participants with a tutorial, which is this thing on the left. They spent about a half an hour with the tutorial, familiarizing themselves with relevant concepts and learning about the function of the tool. And then they completed a main study where they were asked to use the tool to accomplish a handful of sort of day-to-day data science tasks. So those were about 30 minutes and 30 minutes. And then there was, we had a post-interview study in which 4 main themes arose. So the first was people were able to use the tool, which is good. And somewhat surprisingly, despite struggling with understanding some of the basic underlying concepts. So despite the fact that these were data scientists, many of them struggled with things like prior class probabilities, which was important for answering many of the questions. But despite struggling with those, they were still able to achieve their goals. The second is that the tool enabled multiple modalities. So they could operate it in a sequential mode, they could operate it in all at once mode. They could operate it at a granular level or at a low level. And pretty much every participant used every modality that existed at one time or another. So I think this goes to sort of one of the points that Ben was making, that like people like control. They don't want the tool to just like do one thing. In fact, they wanted more control. So they wanted more flexibility to control the modality that they were working with. And finally, and maybe in retrospect, this is something that should be obvious, but many of the participants basically said, I couldn't have done this without the tutorial, which, while obvious in retrospect, I don't know of actually any other study for interpretability that gives people a tutorial on the tool before they enter into a study, which means that they have to learn on the fly, right? So I think if nothing else, one thing I take away from this is like, give people a tutorial, like always, don't not do that. Even though you spend half of your interview time with them going through that. Okay, so in that study, we focused on data scientists as a user, and data scientists are a particularly easy user to focus on in the context of machine learning explainability because they're really familiar with machine learning. But I don't think they're the most interesting user, right? So in the content moderation setting, the people are not data scientists. They're just trying to use a tool to accomplish some task. They don't understand necessarily how the underlying machine learning works and so on. And so when you're trying to help what I'll call normal people, not data scientists, this raises the question of, can you take what you've done for data scientists and just port it over? And what I'd like to suggest is sort of the answer is no. So the dominant approach that's been taken in these settings is to build a machine learning system that solves the task that the person is trying to solve. So do the content moderation task, and then explain the predictions of that model to the person. So basically every paper does that. But it's not obvious that that's the right thing to do. Like, why are we predicting what it is that the person is trying to predict? Like, why is that the right thing for us to try to predict? And among other things, this leads to significant issues of over-reliance, where people just repeat what the system said without necessarily like thinking about it themselves. So in this second project with Masan Noorani and some other colleagues, we looked at this question of like, well, what can we explain instead? And the thing that we looked at in particular is, can we try to flag examples that people might struggle with? So I will skip the details of this in the interest of time, but I'll just give, so we were doing this in a loan context, but I'll give you a slightly easier context, which is, does this food contain at least 50% fat? So who says yes? Who says no? Okay, it's yes. There's a lot of peanut butter on those sandwiches. So the traditional sort of predict then explain would be to say something like, the AI predictor said the answer is yes, what do you think? What we're doing instead is we say something like, the AI has identified that this example may be challenging, please spend extra time on it. And the way we come up with that prediction is we look at past errors that people have made on similar examples. We can, of course, explain both of these predictions as well as just giving the raw prediction. And it turns out that if you give people a predicted outcome on this task, their performance in terms of accuracy on predicting whether it has a lot of fat or not is basically unchanged from giving them no information. But if you give them this suggestion that you should spend extra time on the ones where the system thinks it's going to be hard, their accuracy goes up. So this is obviously super preliminary. This is not, I guess it's on the slide. There's no paper here, but this is one of the directions we're going. So to wrap up, before Joel kicks me off, what I wanted to sort of just highlight is, if we're going to try to build these systems that enable bidirectional communication between humans and machines, I think we need to take seriously, like, what is it that humans need, both in the design and the implementation, and also ask questions about what is it that we should be predicting, and not just take for granted that we should take our automation mindset and just transplant that into like a more human-centered view. There's obviously lots to do more. The content moderation stuff is ongoing. I'm happy to talk about any of this with anyone, and that's it. Thank you.